Hemanta.
You can start, sir.
Okay. Screen is sharing now. 15. Rule number 15.
Yes, sir.
What do you want? What's your name?
Sir, by mistake వచ్చింది. Raise అయింది, sir.
Okay. No problem. No issue. No problem. Right.
Identification marks right. SS lo. So submit చేయబా నేను చూస్తా. నేను ఎక్కడ పెట్టాను
Right, good afternoon, students. Yesterday we discussed about the polymers. What is the polymer? Introduction to polymer, how they are classified, and what is the polymerization? How many types of polymerizations are there? So types of polymerizations are 3 types of polymerizations are there: addition polymerization, condensation polymerization, and copolymerization. So in that, first one is what the polymers, classification of polymers, addition polymerization. This topic is completed. Now we'll discuss today. We'll discuss about the plastics. So before discussing about the plastics, once again we'll discuss about the classification of polymerization. That is, what is addition polymerization, what is condensation polymerization, and copolymerization. Just briefly we'll discuss. So addition polymerization means exact multiple of virgin molecule is called as addition polymerization. Exact multiple of virgin molecule is called as addition polymerization. In the addition polymerization, the best example for addition polymerizations are polyethylene, polythene, polyvinyl chloride, polyacrylonitrile, polystyrene, polypropylene, etc. So in the addition polymerization, double bonds are converting into single bonds. Double bonds are converting into single bonds without elimination of any small molecule takes place. So then we are getting the polymers. That polymers in the addition polymers, the polymers having the long hydrocarbon atom, that means long chain hydrocarbon atoms are present. So that's why in between the carbon to carbon weak van der Waals force are present. In between the carbon to carbon weak van der Waals force are present. So that's why that addition polymers are thermoplastic resins or thermoplastics. So now coming to condensation polymerization. In the condensation polymerization, the monomers having the partially positive and negative charge polar groups. The monomers having polar groups partially positive and negative charge. When partially positive and negative charges are present, removal of elimination of small molecules like water, ethanol, methanol, or NaCl takes place. Then we are getting the condensed polymer. So when condensed polymer is formed takes place, that become hard. 3-dimensional cross links are present. When 3-dimensional crosslinks are present, a strong covalent bond is present in the condensation polymerization. So that polymer. In carbon to carbon, strong covalent bond is present. Why? Because 3-dimensional crosslinks are present. So that's why strong covalent bond is present. So when we are heating, soften. After that become hardened. we can't be softened easily. So like that, plastics are called as, or polymers are called thermosetting polymers or thermosetting plastics. So now condensation polymerization undergo thermosetting plastics. Now, best example of that one is nylon 6, nylon 66, and bakelite, urea formaldehyde, and PET, polyethylene terephthalate, etc. These all are the example for condensation polymerization. Now coming to last one is copolymerization. So in the copolymerization, the monomers having the different monomers having the monomers having the different compounds. So that will undergo polymerization. We are getting the copolymers. So when undergo copolymerization, there is an elimination of any molecules. The best example for copolymerization is buna S rubber, or polyethylene covinyl chloride, etc. These all are about the introduction to polymer and examples, classification of polymerization, addition polymerization, and condensation polymerization, copolymerization. Now, what is the difference between the addition and condensation polymerization? Addition polymerization is called as chain growth polymerization. Condensation polymerization is called as step growth polymerization. In the addition polymerization, double bonds are converting into single bonds, and there is no removal of small molecule takes place. But in the condensation polymerization, small molecules are removed takes place. So in the addition polymerization, long chain hydrocarbons are present, and in the condensation polymerization, branched structures are present. And best example for addition polymers are polythene, polyvinyl chloride, polyacrylonitrile, polyvinyl chloride, etc. Condensation polymerization examples are nylon 6, nylon 66, bakelite, urea formaldehyde, PET, polyethylene terephthalate. Amma, madam.
Sir, are you recording the session, sir?
This recording is going on, huh?
I am unable to record, sir. Now you are host, sir. You have to record.
Okay. Where is that recording option?
Next to
Sir, Alt R on your keyboard.
Alt
R.
Okay. Right.
recording, sir.
It's already recording.
Already recording, ma'am.
Okay, sir. Okay.
Right, these are. So this is about yesterday previous class, polymers, classification of polymerization, addition, condensation, copolymerization. In this, addition, condensation, polymerization is very, very important for you students. So in the examination, difference between the addition or condensation polymerization, they will ask, or I explain the following: addition polymerization and condensation. First, what is addition polymerization? Give the 2 or 3 examples. And next, condensation polymerization, give any 3 or 4 examples. Then that is for 7 marks question they will ask in the examination point of view. Now, next coming to next one is the plastics. So now plastics. Anyone know about plastics? Anyone know about what is plastic? First of all, what is plastic? Give any example. Anyone? Give any example for plastics. Suppose you see, so this is the bottle. So this bottle is made up by plastic only. So this is
PET, sir.
Sir, synthetic polymers are plastics.
Yes, very good. Right, good. So now you see, this is the synthetic plastic. Yes, is it right or wrong? Water bottle. Is it right or wrong? So this is the plastic. Now, what is the plastic? Plastics means plastic is a material that show the plasticity. Suppose you see this is a flexible. Is it right or wrong? When we are pressing, soften. The plastic is a material that shows the property of plasticity and can be molded into any desired shape and dimension. Plastic is the material which show the plasticity when we are molding into any desired shape or desired dimensions by the applications of heat and pressure. That is called as plastics. Plastic having the important properties of a plastic material. So that are low specific gravity. The plastics having the number 1. Listen carefully. So this is a very, very important question in the examination point of view. They will ask about the plastics. So plastics plastics. Plastics having the important properties. Important properties of plastics. So in the important properties of plastics are number one, low specific gravity, low specific gravity, and low thermal and electrical properties, low thermal and electrical conductivities. Number three, easy to fabricate, and the molding process that easy to fabricate and easy to reshape. One more, and chemical, and it having the good chemical and mechanical properties. You see, students, the important properties of plastics are the plastics having low specific gravity, low thermal and electrical conductivity, easy to fabricate, that is easy to mold, and it having the good chemical and mechanical properties. When we are storing any chemical, that does not do any deformation or disintegration. So that means it having the good chemical and mechanical properties. These are the important properties of plastics. Plastics means plastic is the material which show the plasticity, property of plasticity, and can be molded into any desired shapes or desired dimensions by the applications of by using the application of pressure and heat. So easily molded, the plastics are easily molded when we are applying the pressure and heat. So the important properties of the plastics are low gravity, low thermal and electrical conductivities, easy to fabricate, and that having the good chemical and mechanical properties. This is about the properties of important properties of plastics. Now, important applications. What are the applications? Before we're discussing about plastics, what are the applications of plastics? What are the applications of important applications of plastics? Important applications of plastics. Number one, suppose you see mugs. So these are prepared by polythene. These are low density mugs. And the next one, that is overhead water tanks. Overhead these also prepared by polyethylene, but these are high density. Next, pencil box that are made by polypropylene. So what is a polypropylene structure? Polyethylene, H2C, CH2 taken n times. Polypropylene, H2C, CH taken n times. Now one more is audio cassettes. So that are prepared by polystyrene audio cassettes. They are prepared by polystyrene. So the important applications of plastics are mugs that are prepared by polyethylene, low density overhead water tanks are there that are prepared by polyethylene, high density polyethylene, pencil boxes so that are made by polypropylene, and audio cassettes, that is polystyrene. And next one, baby feeding bottles are there now. Baby feeding But there is polycarbonates. Carbonates. One more is toothbrushes that are prepared by nylons. That are prepared by nylons. Now one more is toothbrushes are made by nylons only, and colored. One more is 7 colored toilet sheets or toilet sheets. Urea formaldehyde. And one more is household liquids and bottles like cold drinks, storage bottles are there, no? Bottles for cold drinks. Bottles for cold drinks that are PET. And one more is wide neck jars that are wide neck jars. So these are prepared by, again these are prepared by PET. So you see the important applications of plastics are mugs that are prepared by polythene or polyethylene. So that is addition polymerization. And overhead water tanks are there, and that is that is also made up by polyethylene, that is high density polyethylene. Pencil boxes, that is polypropylene. And audio cassettes are there, na? Audio cassettes that are prepared by polystyrene. And baby feeding bottles are there that are prepared by polycarbonates. And toothbrushes that are prepared by nylon. And toilet sheets are there that are made by urea formaldehyde. And one more is bottle for cold drinks, fruit juices, beers, etc. that are prepared by polyethylene terephthalate. And wide necked jars are there that are prepared by polyethylene terephthalate. So you see, students, these all are applications about the plastics. So plastics, what is by plastic? Plastic is the means plastic is the material which show the property of plasticity, when we are molding. In the molding process, when we are giving the applications of heat and pressure, easily molded to desired shape and easy to dimension, which dimension you want, that like we are getting. So that is called as plastic. Plastic means plastic is a material which show the property of plasticity and can be molded into any desired shapes and dimensions when we are applying the heat and pressure. So it's having the some properties like low specific gravity, low thermal and electrical conductivity, and good chemical and mechanical properties, etc. Now, what are the applications of plastics? It having the mugs. The mugs are prepared by polyethylene, and overhead tanks are prepared by polyethylene, high density polyethylene. Penicillin box that is prepared by polypropylene, and audio cassettes are there that are prepared by polystyrenes, and baby feeding bottles that are prepared by polycarbonates. Toothbrushes are made up by nylon, and toilet sheets, the toilet sheets are the colored toilet sheets are made by urea formaldehyde. And switches, that electrical switches are made up by bakelite. Okay, and elastic type materials are prepared by nylon 66. And bottles for cool drinks, juice and beers that are prepared by polyethylene terephthalate. And wide necked jars are prepared by polyethylene terephthalate. So this is about the properties, that means important properties and important applications of plastics. Now, okay, students. Now you see, these are the plastic bottles. Just you observe the diagram. Plastic bottles that are made up by polyethylene or any material. Plastics. Now, types of plastic products. Sir, are important applications. Types of plastic products are plastic bags, plastic coatings, plastic furniture, And one more is plastic sheets, plastic fitting, plastic tanks, plastic toys, plastic buckets, plastic sanitary ware, and plastic sanitary. So these all are the plastic products. Many types of plastic products are there. Now completely world completely we are depends morning to evening time, each and every person that depends upon plastic only. Is it right or wrong? For drinking purpose, they are using plastic bottle, Tupperware. For storage of food items also we are using the bottles like Cello or XYZ companies are available in market. Chairs. Once you see here, this chair is there and this chair also made up by plastic only. Yes. And insulating pipes are plumbing pipes, etc. And you see plastic sheets, furniture, toys, plastic buckets. Most important that one is plastic bucket or mugs are there. Na? That all are made up by plastic. That all are made up by polyethylene. Okay, these all are the plastic products. The types of plastic products are plastic mugs, bags, plastic coatings, plastic furniture, plastic sheets, plastic fittings, plastic tanks, plastic toys, and plastic buckets, and the sanitary ware, plastic sanitaries. So these are the types of plastic products. Now you see what is plastic. So plastic, once you observe plastic, what is a plastic? Plastic is a material, usually a semi-synthetic solid. So the plastic is a material, is usually a semi-synthetic solid. Monomers of a plastic are either natural or synthetic organic compounds. So when synthetic organic compounds are natural means, so plastics nowadays completely the plastics are made up by either naturally occurring plastic compounds or synthetic compounds. So suppose you see polyethylene, by using the polyethylene we are prepared the mugs or toys or flower vases, etc. Okay, that is also called as plastics. Polyethylene terephthalate is there. That is also one of the plastic compound. PET, simply we are called as PET. This PET are PET bottles. Simply we are called as PET bottles. Why we are called as PET bottles? The storage of cold drinks like juices, Mazza, Fanta, Coke, etc. We are storage in that bottles. So that bottle we are called as PET bottles. Now, plastic. Plastic is a substance that can be easily formed or molded into a desired shape. Plastic is a material which shows the plasticity that can be easily formed, or molded into desired shape or desired dimensions, etc. So plastic can be formed in a desired shape by the effect of mechanical force and heat. The plastics, how we are getting the desired shape? When we are applying the mechanical force or heat, then we are getting the desired shape. In the manufacturing of plastics, raw materials like coal, petroleum, cellulose, salt, sulfur, limestone, air, water, etc. are used. In the manufacturing of plastic raw material, mainly we are used the coal, petroleum, cellulose, salt, limestone, air, water, etc. etc. we are using. Plastics as engineering materials. That means advantages of plastics over the engineering materials. So what are the advantages of plastics over the engineering material? Let us discuss now one by one. So low fabrication cost, low thermal and electrical conductivities, high resistance to corrosion and solvents. So these plastics, that is corrosion resistance, all of them know, and high resistance to solvents, and it having the good thermal and electrical conductivities. That means low. So that are mainly we are using engineering materials. The stress strain relationship of plastics is similar to that the metals. The plastic reduce the noise, vibration. Plastics are bad conductors and heat are useful for the making handles, used for the hot objectives. Most plastics are inflammable. Suppose you see these are bad conductors. The plastics are bad conductors, so that's why we are used as a insulating purpose, or making handles used for the hot objectives. And most of the plastics are inflammable. If the materials that plastics are flammable, that can't be used. The plastics are inflammable. Plastics are electrical insulators, find large scale used in the electrical industries. So these plastics are electrical insulators. For in the household, we are using the insulating purpose. There is the PVC pipes. So that our PVC pipes are made up by vinyl chloride. When vinyl chloride undergo polymerization, we are getting the polyvinyl chlorides. So the polyvinyl chloride, by using that one, we are making the pipes, insulating pipes. Through the insulating pipes, we are passing the wires. And plastics are resistant to chemicals that are easily, that chemical we are storing the chemicals in the plastic bottles or cans or tins. Plastics are clear and transparent so that they can be given beautiful colors. So that plastics are clear and transparent means that bottles are clear and transparent. That looks like good, beautiful colors also that are available in the market. Many types of colors are available. So that are beautiful colors. Simply we are called as. So these all are the important advantages of plastics over the engineering materials. So once again, listen: low fabrication cost, low thermal and electrical conductivities, high resistance to corrosion and solvents. The stress strain relation of plastics is similar to that the metals. Plastic reduce noise and vibration in machines. Plastics are bad conductors of heat, are useful for making handles, used for the hot objectives. Most plastics are inflammable. Plastics are electrical insulators, finding the large scale use in the electrical industry. Plastics are resistant to chemicals. So plastics are clear and transparent, so they can be given beautiful colors. So these are the advantages of plastics or the engineering materials. Gaurav?
Sir,
Once you read the advantages.
is on the sheet. Yes, sir. Low fabrication cost, low thermal and electrical conductivities, high resistance to corrosion and solvents. Stress strain relationship of plastic is similar. Plastics reduce noise and vibration.
Next.
Sir, there is some disturbance, sir. I can't read it.
549. Who is 549?
Gaurang, sir, me.
You only, na? Right. Gaurang, no.
There is some disturbance in the background, sir, so I can't read.
No disturbance.
In my background, sir, in my background. So there's some noise.
Another one. Roll number 55. Who is 55? 55.
Sir,
Remaining 3 or 4 points, once you read it. What's your name?
stress strain.
Once you're on your video.
Sir, it is visible.
Okay. What's your name?
Sridhar. I'm having this stress strain relationship of plastic is similar to that of the metal.
Very good. Next.
Plastic reduces noise and vibration in mechanics.
Okay.
Plastics are bad
Machines,
conductors
vibrations
of heat.
in machines.
Sorry, sir, machines. Plastics are bad conductors of heat and useful for making handles, used for hot objects. Most plastics and inflammable.
Yes.
Plastics are electrical insulators and find larger scale use in the electrical industries. Plastics are resistant to chemicals. Plastics are clear and transparent, so they can be given beautiful colors.
So these are the advantages about plastics. So once you see advantage of plastics. So plastics, mainly the plastics are lightweight, chemically resistant, can easy to be shaped and durable, easy to color, thermally insulating. Yes. So these are and electrically insulating and energy savings. So these all are the advantages about the plastics. Plastics are lightweight, chemical resistance, and easy to shape and durable, and that easy to color or desired color, thermal insulating and electrically insulating and energy savings. So these are the advantages of plastics. So disadvantages. So what is the disadvantage about plastic? It is an indestructible compound. That means what is the mean by indestructible compound? Anyone?
Non-biodegradable.
Very good. Nice. What's your name?
Unsik, sir. Unsik.
What's on your video? 12, 5 12. Unsick. Okay, right. Okay, very good, right, good. It is an indestructible compound, means non-biodegradable. That means we can't be destroyed. The plastic materials are there, na? Polyethylene covers are there, na? We can't be destroy the compound. Thousands or lakhs of years that after that only, if you are buried the plastic material, that can't be disposal, that can't be undergo deformation or disintegration takes place. So that's why plastics, it is an indestructible compound. So even when it is melted, the compound gas that is gives off very harmful gas. When we are burning the plastic compounds, it gives harmful gases. So that is not the eco-friendly. That environmental pollution takes place. Most of the plastic is made from oil. When the world gradually running out of the oil. So this disadvantage about the plastics are it is a indestructible compound, and when we are when we are melting takes place, that gives us fumes are coming to outside. That fumes are not eco-friendly, and the smell is coming to outside. Okay, that is effect to living organisms. These mics and these plastics are made up by oil, made up from oil. When the world is gradually running out of the oil. These are the disadvantages about the plastics. Now this is about the introduction to the plastics. Now very important one. Now we're discussing. Now listen carefully. The plastics. What is how the plastics are classified? The plastics are mainly classified into plastics. The plastics are mainly classified into two types. So what are they? So that are thermoplastic plastics and thermosetting. Next one is the thermosetting plastics. What are the? So these plastics are mainly classified into two types. So what are they? They are thermoplastics and thermosetting plastics. You see, plastics can be divided into two classes. That is, one is the thermoplastics and next one is the thermosetting plastics. So depend on how they are structurally and chemically bonded. So what is the thermoplastics and thermosetting? So this see students, thermoplastics. These are thermoplastics. The best example for thermoplastics are H2C, CH2 taken n times. So this is the polyethylene. So that means it contains a long chain hydrocarbon at CH2, 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 CH2 taken n times. You see, thermoplastics means when on heating, that is easily flexible, and when on cooling that become hard. When we are heating, that became soft only. When we are heating the thermoplastics, that becomes soft. When we are cooling, that is hard. Like that, metals are called as thermoplastics. So in the thermoplastics, in carbon to carbon, weak van der Waals forces are present. So that's why easily deformation takes place. or easily, when we are given the temperature, softening takes place. That means easily melting takes place. Easily melting takes place. So best example for this thermoplastics are polyethylene or PVC, polystyrene, polyacrylonitrile, and polypropylene or polymethyl methacrylate PMMA, and polyacrylonitrile PAN. So these all are the example for thermoplastics. What are the addition polymers are there? Na? That all are thermoplastics. All addition polymers are thermoplastics. Why? Because when we are heating, soften, and cooling, harden, that is called thermoplastics. In thermoplastics, long chain hydrocarbons are present. In between the carbon to carbon, weak van der Waals force are present. So that's why that are softened, and when we are giving the temperature, soften. So this is called thermoplastics. Now, what is meant by thermosetting? Thermosettings are on the molding process, soften. After that become hardened only. We can't be softened. Like that materials are, like that plastics are called as thermoplastics. Thermoplastics in the molding process, when we are giving the temperature, becomes molding process softer. After that, then the temperature is fall down, that become hardened only. That can't be converted into softer. Why? Because in between the carbon to carbon, three-dimensional cross-links of carbons are present. Three-dimensional cross-links of carbons are present. So that's why we can't break the carbon to carbon molecules. In between the carbon to carbon, we can't break. So, suppose you see here, so it contains one carbon is there, carbon to carbon. This is a long chain hydrocarbon in the thermoplastics that is easily breakage. But here in the thermosetting plastics, three-dimensional crosslinks are present. If you are broken this one, this bond is there. If we are broken this bond is there. So like this, three-dimensional crosslinks are present. In carbon to carbon, strong covalent bonds are present. Strong covalent bonds are present. So like this materials, these plastics are called thermosetting plastics. Thermosetting in the molding process become hardened only. We can't be softened. And in between the carbon to carbon, three-dimensional cross-link structures are present, and strong covalent bond is present. We can't broken the bond, so that's why that hard and brittle. So this the best example for thermoplastics are nylon 66, bakelite, okay, bakelite, urea formaldehyde, and Novelac, PET, etc. So these all are the example for thermosetting plastics. Now, so the thermoplastics are, we can easily remold it, but these thermosettings are, we can't remold it easily. We can't remold. Why? Because so that become hard only. So best example for thermoplastics are pressure cooker handles are there, na? That all pressure cooker handles are made by thermosetting. And switches, once you see the switches are very hardened, that can't be melted easily, that withstand high temperatures. 33 kV of temperature also we are giving, power we are giving, that can't be burned easily. So that's why the thermosetting resins or thermosetting plastics having the three-dimensional crosslinks are present, strong covalent bond is present. So that become hardened and brittle only, that can't be softened after molding. Okay, like this plastics are called as thermosettings and thermoplastics. So this is about introduction to thermoplastics and thermosetting. In the plastic, arrangement of the individual units may be linear or cross-linked linear or lightly cross-linked polymers or plastics are called thermoplastics, just we discussed. Heavy cross-links are plastics are called as thermosetting. So thermoplastics, these plastics can be softened by heating and hardened by cooling by any number of times without changing the properties of the material. So thermoplastics means these are when we are heating takes place, soften, and here cooling, harden without changing its properties. So this best example for thermoplastics are polyethylene, polyvinyl chloride, polyacrylonitrile, polystyrene, etc. Yes. So without n times of polymers we are heating, there is no change in the material properties or its. It is thus possible to shape and reshape these plastics by means of heat and pressure. On the application of temperature, that becomes soften only. After that, after cooling, harden. One important advantage of the variety of plastic is that scrap obtained from the old and worn out articles can be effectively used again. That means the scrap of plastic, the scrap of thermoplastics again we are reused. So that is called as thermoplastics. So properties of thermoplastics are soften and liquefies on heating, harden, up to cooling, retain shape after manufacture, suitable for recycling. So these thermoplastics are suitable for recycling, can be reshaped by heat. It may melt before passing to a gaseous state. Allow plastic deformation when it is heated. They are soluble in certain solvents. So these all are the properties of plastics. Plastics are polymers having the same properties. It having that means thermoplastics soften on heating, cooling, harden, suitable for recycling, and can be reshaped easily when we are given the temperature. And before passing, it may be melt before passing the gaseous state. Allow the plastic deformation when it is heated. They are soluble in certain solvents, swell in presence of certain solvents. So these plastics, thermoplastics, are swell in particular solvents. So you see, these all are the thermoplastics. Chairs and plumbing and mugs, tubs, etc. These all are the thermoplastics that can be easily reshaped. Okay, remolded. Thermosetting plastics. The plastics are either originally softened or liquid, or they are softened once upon heating, they harden permanently. We can't be softened after molding. In the molding process, original that molding when the molding process go after completion of molding process become hardened or brittle, permanently hardened only. Permanently hardened. Like that, plastics are called thermoplastics. So they are available in variety of beautiful colors. They are mainly used in engineering application plastics. But the temperature about 343 degrees centigrade, the charring occurs. These thermosettings plastics are durable, strong, and hard. When they are heated in temperature of 127 to 177 degree, they set permanently, and further application of heat does not alter their form of soften them. That means after molding process, we can't be converted into soft. They become hard or brittle only. Permanently hardened. Pressure cooker handles are there, no? The pressure cooker handles are hard and brittle. Switches are there. Switches are hard and brittle. After molding process, that become permanently hardened. So like that, materials are called as thermoplastics. So thermosetting thermosets. So thermosetting plastics properties are permanently hardened and heating above certain temperature, undergoes chemical change during the manufacture, cannot be melted and reshaped, little potential for recycling. Examples uses in thermosetting plastics. So polyesters are there in fiberglasses systems, sheet molding compounds like bulk molding compounds, polyurethanes, insulating foams, matrices, coating, adhesives, car parts, print rollers, shoe soles, flooring, synthetic fibers, that one polyurethane, and vulcanized rubber, bakelites, the phenol formaldehyde resin are mainly used in electrical insulating, plastic ware, urea formaldehyde foam used in polywood, no? Plywood and particle boards, and medium density fiber boards, etc. In that we are using the urea formaldehyde. Melamine is resin is used for the worktop surfaces. Epoxy resins used for matrix components in many fiber reinforced plastics such as glass reinforced plastics and graphite reinforced plastics. So these all are the example for the thermosetting plastics. So properties are maximum same plastics. Plastics properties are same. Already we discussed, no? So these are the thermosetting plastics. So you see, students, what is the difference between the thermoplastics and thermosetting? Anyone can explain the difference between the thermoplastic and thermosetting?
hello.
Gaurang,
Sir,
what is the difference between thermoplastics and thermosetting?
there are some differences, sir. Like maybe one is addition and condensation.
Yes. Tell me, no problem.
One can be molded, another cannot be remolded.
Remolded. Very good. That means reshape. Scrap of metals are reused. Scrap of metals are not reused.
Sir, you melt it again and scrap it, sir.
Yes.
Like how is scrap of thermosetting plastic?
Scrap can't be reused, na. Scrap, that means scrap of material. Suppose pressure cooker handle is there, na, that is broken. That means that is a scrap material. We can't reuse. Okay, scrap can't be reused, can't be used.
Yes, sir.
Okay, so thermoplastics means that is when we are giving the heating, soften, cooling, harden. Thermosettings are under the molding process, harden only. So these thermoplastics are made up by addition polymerization, and the thermosettings are made up by condensation polymerization. So in the thermoplastics, weak monopolar forces are present. In the thermosetting, strong covalent bonds are present. And thermoplastics, it contains the long chain hydrocarbon atoms. Thermosettings contains branch structures. Three-dimensional plastings are present. They can thermoplastics they can be remolded, but thermosettings we can't remold it. Scrap of metals are reused in the thermoplastics. That scrap material we can't use. The resins are soft and weak and less brittle. So the resins are usually hardened and strong and brittle.
Sir?
Only.
Is reason for cross-linking in thermosetting reason for hardness cross-linking in?
Yes. Okay, I will explain. You see, we have time now. Time is there.
5 minutes is less.
Okay. I will explain. You see, suppose bakelite is there. We will take the bakelite. Okay, bakelite polymer. So the monomer of bakelite is phenol plus HCHO. So when this will undergo polymerization, that we are getting the three-dimensional cross-link structure. So that is once you see the structure of this one, OH, CH2, OH, CH2, CH2, benzene ring, CH2, CH2, benzene ring. You see, in between the carbon to carbon, three-dimensional cross-links are present or not? Gaurang?
Yes, sir. SP2
so that's
hybrid.
That's why that become hardened. Whatever you take, suppose nylon 6,6 you take up, caprolactam you take, any one you take, or urea formaldehyde, NH2, C double bond O, NH2, yes, plus HCHO, that is formaldehyde, that form as a HNCH2, C double bond O, HN, CH2, NH, C double bond O, NH. So taken n times. So this is the structure of urea formaldehyde. In between the carbon to carbon, three-dimensional cross links are present. A strong covalent bonds is present. So that's why that can't be broken. That can't be softened. That can't be broken easily.
Sir, but in that process of making bakelite, first novolac is formed. Then when we treat it with excess of aldehyde, we get bakelite.
Yes. So just for idea about that one, I'll give the structure. Okay. First, when the phenol is reaction with the formaldehyde, that first form is a monomethyl phenol. That means one methyl phenol formation takes place at ortho position. Then After that, 2 moles of formaldehyde reaction with each other, then form as a dimethylphenol. 3
Coupling
moles of
takes place.
yes, 3 moles of formaldehyde reaction with the formaldehyde, that trimethylphenol formation takes place. The trimethylphenol or monomethylphenol, dimethylphenol is reaction with each other, that form as a novolac. That novolac undergo polymerization. When we are polymerization takes place, we are getting the bakelite. So that's why that bakelite that are mainly we are used for ball bearings or switches, etc. Our pressure cooker handles are there, na? So that are also made up by bakelite. So this is the difference between the thermoplastic and the thermosetting. Okay, students. Tomorrow we'll discuss once again the difference between the thermoplastics and thermosetting. Okay, thank you.